It has. Okay. I did not know it had been that long. 52 and 53. 52. 51. Miley bought a computer for her home office and depreciated it over 5 years using the straight line method. If its initial, that's because we didn't do that. I'm sorry. Skip that one. Is it the straight line method too? Yeah, I'm sorry. Skip those two. 51 and 52. I apologize. 53 you can do. That's on your calculator. Yes. Yep. Huh? I was wondering if anyone was going to ask about that one. That was A-Rock all the way through. That's right. So you've got these three functions, f of x, g of x. Oh, you've got more than just three. Whoa. It's not. Ooh. My brain is starting to get fuzzy with if I'm in calculus or pre-calculus or algebra 2, what y'all know and what they know and what. Because we're doing A-Rock and I-Rock in calculus. Okay. Compute the average rate of change of f from x equals 1 to x equals 3. This is for f. Well, f of 1 would be 1. F of 3 would be 9. So this is the 0.11 and the 0.39. And so all I'm going to do is do the slope between the 2 points. So 8 over 2, which is what, Carter? How you do that, I don't understand. So the average rate of change is 4. That's all you have to put is 4. Do y'all need me to do all of them, or are there certain ones? You really don't? Are you being serious? What? All right, so part B is A-Rock for F from x equals 2 to x equals 5. Where do you see that? I'm not sure what you mean. I'll look at it. All right. F of 5 is what? Go, Carter. F of 5. Right. It's just referencing different equations from the beginning. Wait, how did you get that? I used the equation F because that's what I'm talking about. So I'm going to do 25 minus 4 over 5 minus 2, which is, from the problem, it said compute the rate of change from x equals 2 to x equals 5. It's part A said from x equals 1 to x equals 3. What else? Anything else on those with the variable? Like F? You did. Anything else? Going once? Yeah. Whichever. What else? Speak now, forever hold your peace. All right, quadratics. Here we go. Tell me, what is a quadratic? Okay, its graph forms, not a U, what do we call it? Oh, that's called union with the U, yes. All right, we get a parabola. Tell me some things about a parabola. Okay, close, Carter. It's even whenever the parent graph is even, yes. But okay. X squared. So the parent, you're telling me the parent graph is, and that is an even function. Tell me something specifically about a parabola.
It's got 3 points usually.
Yeah, no, we're still in 2-1, yeah.
They're parallel. Oh, thank y'all.
It could be up or down, right? Somebody said something about bounded. It is always bounded. It's either bounded above or below, depending on if it's up or down. Tell me some special parts of the parabola, though. The vertex. They all have a vertex. That vertex is also a max or a min. In this case, it would be a minimum. In this case, it'd be a maximum. Is it relative or absolute? Absolute. What goes through the vertex? The line of symmetry, also known as the axis of symmetry. Tell me how we can write the equations. There's 3 different ways we can write equations. Because it never goes higher than that point. Okay, now give me 3 ways I can write the equations. 3 ways, not the parent graph, but 3 ways I can write the equation of a quadratic. A quadratic. Vertex form is one of them. What does it look like? Sorry. Yes. This is vertex form. There's a standard form. What does standard form look like? Huh? Different ways, kind of like you have whenever you have lines, you can write them in slope, intercept, point, slope, standard form, same thing. How about, what's the one I'm missing? Intercept, that's exactly right. What does intercept look like? You're actually exactly right. I was fixing to write it. Oh. I was like, wow, Carter. This is intercept form. We also call this factored form. Why do we call it factored form? You're exactly right. If I take standard form and I factor it, I end up in intercept form or factored form. Now, it's easy for us to get, and this is probably where we're going to stop today is what I'm fixing to show you. But it's easy for us to get, actually before I get to that, there's a common variable in all of these. What is it? Okay, besides x. A, that A, right? What does that A tell us about the equation? Because it does the same thing in every single one.
Stretches or shrinking?
If A is positive, I'm opening up. If A is negative, I'm opening down. And then as the absolute value of A gets smaller, which one? You actually could be right with either one. So we're going to say vertical This is less than 0. A vertical shrink, which means if it's a vertical shrink, that means it gets wider. The smaller the A value, the wider the graph. And then, yeah. The same thing as a horizontal stretch. If A is between 0 and 1, that's a vertical shrink. Stretch. Wait. That is opposite. Wait. This is between. It's not Aiden, it's me. There we go. Sorry. This one is bigger than 1. Golly. Break. That's a vertical stretch. Also known as a horizontal shrink. Which means I'm getting skinnier. Y'all remember all this? Okay. How do you solve a quadratic that's in standard form? If I want to solve, let's say what would my steps be to try to solve a quadratic? So what are you trying to do if you do A times C? Factor it. You're going to always try to factor it first. What if it won't factor? Quadratic formula. That's the one we're fixing to talk about. Oh, just wait. Before we get into solving, we're going to talk about manipulating into other forms. I feel like I had y'all do this in Algebra 2. I did it with one group. I can't remember if it was y'all or not. How can I go from, tell me the advantage of using the different forms. What's the advantage of vertex form?
Knowing the exact location
of the vertex without doing any math, right? Because, yep, that's your vertex. HK is your vertex. H being opposite sign, K being same sign. So let's see, that's exactly right. Let's say I was 1/2. What would the vertex there be?
Right, down 3.
-1. You didn't learn this in Algebra 2? Huh? Opposite sign. Remember, because that's moving it left. It's okay. It's all right. What's the advantage of intercept form? It finds the zeros. You're exactly right. It finds the solutions, the x-intercepts, the zeros, all meaning the same thing. What's the advantage of standard form? The y-intercept. You're exactly right. A does the same thing in all of them, but all of them give us a different little piece of information. So here's what we're going to do. I'm assuming that you can take this form and put it in standard form. If I wanted to put this in standard form, to get to standard form from any other form, all I have to do is FOIL, right? I can't distribute that exponent, so I'm going to have to FOIL. So I didn't plan on spending time on this, but if y'all need it, that's okay. Y'all have to tell me when you haven't seen something or you don't know or whatever. I know we hit this in Algebra 2. So now I can multiply things together, but I can't multiply more than 2 things together at one time. So I'm going to leave that 1/2 out there, and I'm just going to multiply these out. X squared plus x plus 1. If you can do that FOIL in your head, that's okay. You don't have to show that extra step there. Now I need to take the 1/2 through. And combine like terms. 3 is the same thing as what? 6/2. So I get 1/2 x squared plus x minus 5/2. And now I'm in standard form. Y'all all okay there? Okay. There. So I multiplied these two together first, simplified it, and then I took the 1/2 to everything. Combine like terms. 3 became 6/2, so I could combine it with the 1/2. Gave it a common denominator. You're not going to be able to see back there, are you, Robert? Plus 1/2, it said minus 3, but I scratched it out and made 3 6/2. Because 3 and 6/2 are the same thing. I need them to have common denominators. So now the question becomes, I can go from vertex or intercept to standard by multiplication, right? But what happens if I need to go to standard to intercept? You've already told me this one time. Factor. What if I need to go from standard to vertex?
FOIL. Minus b/2x.
Tell me what you're doing.
What is that equation called?
But it may not necessarily give me the right thing. You're finding the vertex, but how can I get it? How can I manipulate? I don't think we did this. Okay, to go from standard to intercept, I factor, right? But what if I need to go from standard to vertex? I'm gonna just tell you. How did you know that? Did Maddie say that? How did you know that? Yeah, but it was the right random thing. Like who? Did he look it up? Golly, I was like, holy cow. We're going to complete the square. Okay, those of you that I did not have for Algebra 2, did y'all learn to complete the square? Okay. 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 Then let's go back and review. I'm sure my guys could use some review too. Standard. That is exactly what it is. That's the square dancing one. So let's talk about what makes it. Let's talk about a perfect square trinomial first. Okay, because that's what we're trying to get is a perfect square trinomial. So a perfect square trinomial is when the ends. I don't want to use x. So if the ends are perfect squares and you take the square root of both ends and you multiply them together, so ax b, I should have just used a and not x. Yeah, let's change it. Oh my gosh, y'all. It'll be less confusing for you to do it this way. Thank you, Carter. The ends are perfect squares. If I take the square root of both ends, what's the square root of the first one? What's the square root of the last one? B. Those have to be perfect squares. The last sign has to be a plus. The first sign could be a plus or a minus, it doesn't matter. If I multiply these together and double it, it has to give me what's in the middle. So it does the square dance. Square, square, multiply, and double. Okay? Square, square, multiply, and double. The square root of the first, the square root of the last, multiplied together, and then doubled. If that happens, then to factor it, whatever this first sign in goes in the middle, and you just put a squared here. So what we did when we completed the square was we would go to solve an equation, and what would happen is that equation would not be a perfect square, but we'd force it to be a perfect square. For example, x squared plus 6x plus 7 equals 0. And it said solve by completing the square. And the first thing I'd want to do is say, well, is it already a perfect square trinomial? No, it's not a perfect square trinomial. So it doesn't factor. My square is not complete because it's not a perfect square. So the next thing, I said, well, do I have a leading coefficient here at all other than 1? No. If I did, I'd need to divide everybody by that leading coefficient. We'll do several examples like that. But then next question is this C that I've got here, since it's not a perfect square trinomial, it's a bad C, right? It's no good. It doesn't make perfect. So I move that to the other side. And then, no, I'm going to show you a different technique for doing it, but I'm just reminding you of what we did here. So I have plus 6x, and we put this blank on this side. We move the 7, and we leave a blank on this side as well, because whatever we put on one side, we have to put on the other. And now I find that good C, that one that makes it square dance, right? And how do I find that? Uh-huh. Right. And that goes in both holes. So I have 9 and 9. So to find a good C, you take B, divide it by 2, and square it. That'll always make it square dance. Yep. Because it's an equation, I got to keep it balanced, right? If I add it to this side, I have to add it to this side. How does the left side factor? X, the first sign is plus 3 squared, what's it equal? 2. Now, if I was solving this, I could solve easily now, right? What would I do? Square root, right? Square root on both sides and then subtract 3. Yeah. But what if I wanted this in vertex form? Look how close it is now, though. Well, why don't I just move that 2 over? What's the vertex of that quadratic? -3, -2. So instead of using completing the square to solve, we're going to use complete the square to write it in vertex form. I'm going to give you some steps because y'all have asked me for that. This one I can give you steps to, huh? Y'all leave him alone. Do you feel bullied, Robert? No, I'm not. Would you like me to run you the sheet that I give them in Algebra 2 on how to complete the square? Oh, y'all all want it? So that we can get it in vertex form. That's going to be the goal. In Algebra 2, we completed the square so that we could solve it. In pre-cal, we complete the square to get it written in another form. Okay, let's just run through quickly the example on your sheet just so you see. Great day. Did I exit out of it? Oh, it's in. If you look, there's an example with steps on how we run through and complete the square in order to solve, checking for a perfect square trinomial, and then running through the solving process. When in this class, when we get to number 5, we're going to do things a little bit differently, but just so you see, so you remember. All right, here we go. Do you, Robert, at least remember about a perfect square trinomial? Okay. This is going to be number 32 from your homework. I think it is anyway. So the directions for this say to find the vertex and axis of symmetry, but what I'm going to tell you to do is not to find the vertex and axis of symmetry by doing opposite b over 2a, but rather by completing the square. And you'll see why we have to do this a little bit later on. This comes up a lot. So I'm going to change the directions. Complete the square to find the vertex. All right, here's what we're going to do. First thing we're going to do, what'd you say? You're actually right, but I'm going to do it a little bit differently, okay? Surprisingly. Step 1. Factor the leading coefficient from the first 2 terms only. Okay, so I'm not going to do it from the whole thing like I had done before. So here I'm going to have h of x equals, if I factor it out of just the first 2 terms, now I am factoring -2, so I have x squared plus what's left in the middle. It doesn't divide by 2. 7, no. What'd you say, Law? Over 2. That's exactly right. 7 over 2 x. Just like before, I'm going to leave a hole. Okay, because I'm going to put something in this blank right here. I'm going to close, but don't forget this -4 that I had. We haven't got to that step yet. Right now, all we did was take out the leading coefficient. Factor the leading coefficient from the first 2 terms and leave a hole. So all I did was divided by 2 from both of these and put it on the outside. I haven't done anything with complete the square yet. Just getting rid of that. Okay. Here's where we just start digressing from the way we used to do it. Okay, so stay with me. It's the same thing. It just looks a little bit different. I need to find a good C. I'm going to add it to my whole, but at the same time, I'm going to subtract from the end of my equation. Let me show you. I didn't divide it by anything. I only took it out of the first two. I'll show you why I say careful here. All right, so my good C, I know, I said it was B over 2 squared, but since I have a fraction, I'm going to say half of B squared. Right? Does that make sense to you why I'm changing that? Instead of dividing by 2, I'm multiplying by the reciprocal. Since B is already a fraction, instead of dividing it by 2, I'm going to multiply it by a half. So half of 7 over 2 squared. Now, add it to the whole. And I told you to subtract from the end, and I said be careful. Before I added it to both sides, right? Say right, because that's right. Why did I add it to both sides? But you're right. Before, what I'm saying, you're right in what you're thinking. Yeah, no, that's okay. Before I added it to both sides because it's an equation and I needed it to stay equal, right? But now, since I'm working on the same side, I need to subtract whatever I added in there to keep it balanced. Okay, kind of like if I had x plus 3 equals 12. Well, if I do anything over here, if I said, okay, well, I'm going to do this, I'm going to add 5. I could add 5 and subtract 5 at the same time, and I really haven't done anything, right? I've not changed any values. I'm doing the same thing here. I'm adding here, but I'm also going to subtract it here. But the reason I say be careful is I'm not going to subtract 49 over 16. What do you think I'm going to subtract? Give me that. How much have I added to the right side? Did I add 49 over 16? How much did I add? You're making it too hard. 49 over 16 times negative 2 is just negative 49 over 8. You've never done your fractions like that before?
I just like look at it and usually there's multiple choice. How is that even? What did you do? 45. Oh, I guess. I'm so hard for my day one.
Okay, if you don't know how to do that, take out your calculator, do 49 divided by 16 times negative 2, and then hit math, enter. 49 divided by 16, multiply it by negative 2, and then math, enter. $49 divided by 16. Oh, excuse me. Hit math, enter. Times negative 2. Okay, yes. So we're subtracting negative 49 over 18. Over 8, sorry. Over 8. Okay, I'm just going to rewrite this part so you see. I have h of x equals, that's the hard part. What'd you call me? What'd you call me? He was signed out at 1:15. I told him before. All right. Is everybody okay? I know this is difficult. That's why I said I figured we'd stop after this one. We're just going to, I mean, not this particular example, but this concept. Yes. He's probably crawling on the ground in there, yes. All right. Now what do I do? Well, it's downhill from here. I'm just going to factor and simplify. So I have the negative 2 outside. This is now a perfect square trinomial because I just forced it to be a perfect square trinomial. So to factor it, it's the square root of the first sign, the square root of the last, squared. And now I just need to know what this simplifies to. So on your calculator, if you don't want to do the math, this would be negative 32 over 8. 32, 117 over 8. Say again. I just made it have a common denominator. 4 times 8 is 32. So 32 divided by 8 is 4. What square? I factored it. It's this, you talking about this one? I factored the perfect square trinomial. So the whole point in the perfect square trinomial is that, remember, it factors like this. The square root of the first, square root of the first, and the square root of the last squared. So I did the same thing. The square root of the first and the square root of the last. If you FOILed this out, you'd end up back here. What's the vertex? If you do this, this is the kind of stuff that calculus gets held up on all the time. It's not the calculus, it's this kind of stuff. That's why we're spending time. Where are you lost? Which part did you get lost?
I got lost.
I feel like if you put a problem with it, I'll really
He left. Let's do another one. I know. No. No, we're stopping at this concept. Oh, this is like a third of the quadratic stuff we have to do.
So like, but if you put one up here for us to do, I would not know where to start.
If what?
If you like put a problem there, like.
That's what we're going to do. So I want to walk you through because it always takes a long time and it's confusing when I'm explaining initially how to do it. Now let's work through. So keep your 3 steps here beside you, right? And let's look. This is 33 from your homework. This will be a little bit easier one. Y'all fuss when I do an easy one first, but then you fuss if I don't do an easy one first. Okay. Let's complete this. But if I do an easy one first, y'all go, oh, that's easy. We know how to do that. We don't need another example. And then you don't pay attention if I do a hard one, and then you can't do your homework. Okay. All right. Well, this is the easy one. We did a hard one with the fractions and stuff. This one's not as hard. Y'all want to do the harder one from your homework? Okay. Complete the square to write it in vertex form. Then we'll identify the vertex and the axis of symmetry. So my first question, my first step, factor out the leading coefficient from the first terms and leave the whole. Why can't you do that? It's just 1, right? So it's just x squared minus 4x. I'm still going to leave a place for that whole, but I'm going to do a plus 6 here. Well, because is 6 a good C, a perfect square? No. In fact, let me do it like this. How about that? I factored a 1 out. That's whenever I'm solving. So that was what we did in Algebra 2. Here, we're keeping everything on the same side. What plugs the hole? What completes the square? What value can I put here that's going to make it a perfect square trinomial? 4. How did you know? Now, I add it here, but I subtract it here. No, you don't. It doesn't matter because if you square a negative number, it becomes positive. So what am I subtracting here? 4. Whatever the A times the good C is, that's what you're subtracting because I have to stay balanced. Now clean it up. How does this factor? What is 6 minus 4? What's the vertex of my parabola? Axis of symmetry? X equals 2. It's always the x equals because it's a vertical line. Una más? For what? For this? X minus h squared plus k. That's your vertex form.
And then once you get it to like, when you fill it in for the scene, you just put it in that thing.
Yes, it's the square root of the first sign, and the square root of the last squared.
So the first, right, the square root of the first one,
Mm-hmm.
and the last one.
Mm-hmm. With the first sign in the middle. Because 6 minus 4. Let's do one more. Hard or easy? Medium. Let's do number 3. Same thing. That's exactly right. I want to put it in standard form before I do anything else to make my life a little easier. All right, what do I do first? Yeah, try it on your own, then we'll do it together. Try it on your own. Say again? The first one. Take the 4 out of the just. Great day. Just the first 2. Thanks, guys. I appreciate the support. Y'all are so nice. Good C. Half of the middle squared. So I want half of a half squared, which is a fourth squared, which is 1/16. I add it here, but I subtract it here, but I don't want to subtract the 16th. What am I subtracting? A 4. 4 times 1/16. That's exactly right. Multiply here, and it gets subtracted here. Okay, so if you take the leading coefficient out, that means divide by that number in front, right? We're backwards distributing. So it leaves me with x squared, and then if I divide 2 by 4, I get 1/2. No, 1/2 plus 1/2 would be 1. Right, so it's 4 times 1/16, and that's what gets subtracted here. This is always A times C. So I had to divide by the 4 there. So it's 4 times x squared minus, and then I had that 2x that I divided by 4, which is 1/2. The ones with the coefficients and the fractions are hurting us, aren't they? Yeah, that's where we're stumbling around. All right, factor the inside here. X, first sign was 1/4, that's exactly right, squared. And now I just need to do 6 minus 1/4, which would be 24 minus 1, 23. But it's going to be positive 23/4. So what's the 6 minus 1/4 is the same thing as 24/4 minus 4. Vertex is poor Robert. Do y'all think you have enough knowledge to do this on your own? Do we need to do another one? So whenever you do b over 2 squared, you can also write that as 1/2 times b squared. So if b is ever a fraction, I always go with this. If b is a whole number, I go with this.
So I would have actually done
The 1/2 times. Since it was a half, it was only a fraction.
that's only the time.
Correct. That's to find this c on the end, and then whenever this c here, whenever I want to find what I add, what I subtract over here, I have to multiply by what I took out in the beginning. Yay or nay? Nay? Nay because it's hard, nay because you don't want to do it. We got 5 minutes. I can run through another one if you want me to. You got 27 through 38 tonight. We've done 3 of them together. I'll do another one with you if you want me to. Yeah. Okay. If you don't want it, you can go ahead and start your homework. If you do, it's coming from your homework anyway. On page 163. Huh? 30, 33, and 32. 32, 33, and 30. We'll do 38 together. You're welcome. Yeah. Complete the square to write in vertex form and find the vertex. Since we're short on time, I'll just run through this one with you instead of giving you a chance to do it. I'm going to first take the A out of only the first 2, but I'm going to leave a hole. Now I find my good C, and to do that, I take B, divide it by 2, and square it. Every time. That's what forces it to square dance. I can't just subtract 25 over 4. It has to be 5 times 25 over 4. That's what I subtract here. So what's 5 times 25? 125 over 4. 25 times 5 is 125.
So once you put it in the blank, you also have to.
Yes. Yes. This last one is always A times C. All that's left to do is factor and clean up. I keep that 5 in front. How does this factor? Square root of the first one is x. The first sign is minus, and what's the square root of 25 over 4? That's right.
Don't deal with the 5 in the middle.
Nope. If you FOIL that out, it'll pop back out. This is really just a factored form. It's x minus 5 over 2, x minus 5 over 2, and if you multiply it, it'll show back up. I do. Yes, this is going to be 48 over 4. What's 48 minus 125? That I don't know off the top of my head. What is it, 70 what? 77? I don't know. Look at you, Sophia. What's the vertex? Axis of symmetry?